A positive charge of 50 microcoulomb is placed in an electric field of 100,000 Newton per coulomb, directed in the upward direction. What mass should the charge have to remain suspended in air? So we have a positive charge, and it says the electric field is directed upward. It means that the electric field is going this way. So it means that this electric field push this particle toward up. So we have electric force toward north. And it says what mass should the charge have to remain suspended in air. So if it's suspended, it means that we need to have exactly the same force going down, which is the gravitational acceleration, and it is m times g. So in order to be suspended in air, sigma Fy has to be equal to 0. It means that F has to be equal to mg. F is E times Q, electric field times the charge of this particle, and that has to be equal to mass of the particle times gravitational acceleration. So m will be E times Q divided by G. E is given 100,000. Q is given 50 times 10 to the power of negative 6 divided by G, which is 9.8. That's going to give me 0.51 kilograms. So that's going to be the mass of the charged particle.